Hi everyone. Today we will discuss about the group multiplication table. Okay. So next we have group multiplication. Group multiplication table. So we have to form this table. Okay. So let's see how to actually form this kind of group multiplication table. So initially we are taking a simple molecule which is your water molecule. So now I think all of you know what is the point group for your water molecule. So the point group which actually exists for your water molecule, that is what? That is your C2V point group. Okay. So in C2V point group, what are the elements we have? So we have C2Z axis. Okay. So along Z axis we have C2. Okay. And apart from that we have 2 sigma V. Okay, we have 2 sigma V, and we have also identical element T. So basically this identical is present in all the molecules. Okay, identical is present in all the molecules. Okay, and this identical elements do nothing. Okay, do nothing, but yeah, these are the things you already know. So in C2V point group, what we have? We have C2Z axis and we have 2 sigma V. What are the sigma v we have? So we have sigma xz and sigma yz. Sigma xz and sigma yz that we have. So now if you see, so how to form this group multiplication table? So initially we have C2V point group. Now what are the elements we have present? So you just write down that identical comes first, E. Okay, then you have what? C2Z. Okay, next you have 2 sigma V. So we will basically write down sigma xz and sigma yz. Xz yz you know. So this is your x axis and this is your z axis. This is x axis, z axis. So this plane consists of what? Sigma xz. This is your xz plane, and here this will be your y axis and this will be your z axis. So this plane consists of what? This plane is actually your yz plane. So these are the two planes we have. Now write down the elements here also. So here you have E, then you have C2Z, then you have C2Z, then here you have sigma xz, and here also you have sigma yz, sigma xz and sigma yz. So if I multiply with E, anything if I multiply with E, I will get that thing only. So these are the two things you have to arrange it like this. You have to arrange it like this. So E into E or E cross E, you will get E only. Now E into C2Z, that also you will get C2Z only. E into sigma xz, you will get sigma xz. E into sigma yz, that one also you will get sigma yz. Now C2Z into E, that one also you will get C2Z. C2Z into C2Z. So that means what? C2Z into C2Z means what you are getting? This thing, C2Z into C2Z. So that is basically your C2Z square, or you can write down identical. Okay. If you multiply two times a single element, so that will be equal to your identical. Next what you have? So next you have C2Z into this C2Z into sigma xz. So if you see the the elements, what are the elements you have? So identical you have. Identical, how can you get the identical? C2Z into C2Z. So same element, if you multiply by two times, you will get identical. Now C2Z into sigma xz, so if you multiply these two, okay, if you multiply these two, you will get the other one. Okay, otherwise you can do in the previous class like what we have done, that in the previous class we have done that symmetry operations, they are in multiplication. I have actually shown that how to find out this, right? So similarly you can find out C2Z into sigma xz. So C2Z cross sigma xz, you will get sigma yz. So you just write down, so C2Z I am multiplying with sigma xz, I will get what? I will get sigma yz. Similarly C2Z into sigma yz, if you multiply this C2Z with sigma yz, you will get what? You will get sigma xz. Okay, now sigma xz into E, what you will get? So anything if you multiply with E identical, you will get the same element, so you will get sigma xz only. Now sigma xz into C2Z, so again you are multiplying these two, sigma xz with C2Z, so you will get what? Sigma yz. Okay, now sigma xz into sigma xz, so if you multiply 2 times sigma xz into sigma xz, what you will get? You will get identical element E. Now sigma xz into sigma yz, so if you multiply these two, sigma xz with sigma yz, see here you have sigma xz, you are multiplying with this sigma xz into sigma yz, so you will get the other one. What left? C2z, so you will just write down here C2z. Now last what you have? Sigma yz, so sigma yz into E, you will get sigma yz only. Okay, now sigma yz into C2z, sigma yz into C2z, you will get what? You will get sigma xz. Okay, now sigma yz into sigma xz, if you multiply sigma yz into sigma xz, so you will get C2z. Okay, and sigma yz into sigma yz, so that one you will get identical. Okay, so like that you have to form the table, and this is the whole group multiplication table we have. So in the corner, if you see in the corner, what we are getting? E. So this is your whole group multiplication table. This is your whole group multiplication table. Fine, so in that way you can find out the group multiplication table. Okay. Okay, fine. So next we have write down, next we have order of the point group. Order of the point group. Okay, so order of the point group. So what do you mean by order of the point group? So first of all, order means what? So you just write down that total number of symmetry operations, total number of symmetry operations present in a group. Okay, so total number of symmetry operations present in a group. Okay, so this is basically order. Order means what? Total number of symmetry operations present in a group, or you can say that total number of symmetry operations you need to apply on a molecule to get the original configuration back. Okay, you can also say that total number of symmetry operations present in a group, or you can write down like this, that sorry total number of symmetry operations present in a group. Okay, or you can write down that to apply on molecule, to apply on molecule to get original configuration back. Original configuration back. Okay, original configuration back. So this is the thing. So we have some formulas, we will apply them. Okay, we will apply them. So suppose you have cn point group. Okay, suppose you have this, so you just point out here that number of operation. So if you have cn, so here you will have n minus 1 number of operation. Okay, so cn is the point group and you will have n minus 1 number of operations. So suppose you have c3. Okay, so suppose you have c3, so that means you will have 2 operation for that. Okay, and if you add identical, because identical we are not considering here, this e1 is actually present for each and every one. Okay, so here we are not including here. Okay, if you add the e, so that means you are getting total 3 operations. Okay, similarly if I write down c4, so n minus 1 number of operations should be present here, so 3 operations should be present. Okay, apart from that you can add the identical, so total you will get 4. Okay, if you have sigma, okay, plane of symmetry, if you have plane of symmetry, so that means only one operation is present there. Okay, only one operation is present, so that means if you have c3, so you have to operate for 2 times. If you have c4, you can operate for 3 times. Sigma you have to operate for 1 time. Okay, and you can add the identical with that, so you will get 2. Suppose you have this inversion center. Okay, so there also you will have one number of operation and you can add the identical one, so you will get 2. And if I write down e, so that means the identical you will get only 1. Okay, so these are the things we have. Okay, these are the things we have. Fine. So similarly I can say that suppose I have water molecule. So in water molecule, what is the point group we have? We have C2V point group. So in C2V point group we have C2 axis. Apart from that we have E, sigma xz and sigma yz. So in C2 you will have 2 minus 1 number of operation, 1 operation. For identical, 1 operation, sigma xz 1 operation and sigma yz you will have 1 operation. So total you have 4 operations for this C2V point group, or I can say for water molecule. Okay. Fine. So suppose I have one molecule like this. Okay, carbon carbon double bond is there. This side you have H1. Okay, this is your H2, and this side you have F1, F2. So what I can apply here? So if I apply this, okay, inversion center, if I apply this inversion center, so what I will get? So carbon carbon double bond is there. Okay, so what I will get? I will get F2 will be here, F1 will be here, H1 will be here, and H2 will be here. Okay, so if you apply that, you will get this. Now the thing, this is what, this is basically your equivalent orientation. This is your equivalent orientation. Now if I apply this identical for another, sorry, this inversion center for another time, if I operate this inversion center for another time, so that time what I will get, so that time they will again interchange their position, f1 f2. Okay, here you will get h1 h2. So this is basically what, this is your identical orientation. Okay, so if I operate the inversion center for two times, you will get the identical orientation. Okay,
কারেন্ট আসবে ফোনটা কিন্তু চার্জ নেই 8% আছে
current IC book.
তাহলে ঠিক আছে মানে ফ্লাশটা পুরো মালিকানা ফোনটা করতে দিতে পারে সুইচ অফ করে গেলে
দেখছি তো চার্জার আছে, ওকে আসছে দে
আমার পোস্টে
পালাই।
আমার ওষুধ দেন কারেন্ট না বলা আগে লাগাই দিবে
এখানে লাগাই দে।
এখন লাগাবো আমি ফুটিয়ে দেবো ফোনগুলো আজকে যখন দেখবে টানা করে লাগাই দিবে
Okay, fine. So next, one thing we think we have done already, one thing, that is what, that is your improper axis of symmetry. Improper axis of symmetry. Improper axis of symmetry. So suppose I have BH3 molecule. So here I have H1, H2, H3. So this is the molecule. Now if I rotate this molecule around your C3y axis, okay, so C3y means, you know, this axis I am talking about. Okay, so this is your C3y axis. So if I rotate the molecule along this C3y, suppose I am rotating in clockwise motion or anti-clockwise, anything, so what will happen, so basically H2 will come to here. Suppose I am rotating in clockwise direction, so H2 will go to there. Okay, H1 will come here and H3 will come here. So this is basically C3y. Now if I operate this sigma xz plane, so xz plane means what, so this is your x axis, this is your z axis, so that means this plane. Okay, this plane is basically your xz plane. So if I keep this plane in front of this molecule, okay, suppose I am keeping this sigma xz plane in front of this molecule, so that time what you can see, tell me what you can see. If I keep this plane in front of this molecule, so you will be only able to see that molecule only. Okay, but only one minor change will be there. What is the minor change? You can see the back face of the molecule. Okay, you can see the back face of the molecule. Okay, so initially we are rotating the molecule by C3 axis. Okay, and that time they are interchanging their positions, and then I am taking the perpendicular plane of that. So basically you are getting equivalent structure. So S3, so that means what, I am getting C3. Initially you have to apply C3, then you have to take, or you have to operate perpendicular plane of that. Okay, perpendicular plane with respect to that. Fine, clear. So I can say that C3y sigma xz, I can so basically if I say, if I like do like this, suppose you have B, okay, then what you have here, you have H1, this side you have H2, okay, and this side you have H3. Okay, now suppose I am not writing like that C3y and sigma xz, directly I am writing that I am operating S3 axis for one time. Okay, S3 one time. So what directly I can write down, C3y sigma xz. If you operate, you are getting this, right, mirror image of this, na? So basically I can directly write down that suppose you have H1 H2 H3. Okay, suppose I am starting from here, so what I will get, I will get boron is here, then what you are getting, tell me. H2 is coming to here, okay. uh, H3 is there, and here you have H1 that is there, okay. Now suppose I am operating another time S3 2, so I am operating S3 2 for another time. So that time what you can see, so that time basically H3 will go to there, okay. H3 will go to there, no sorry, H3 not H3, H1 is there, H2, okay fine. So okay fine. So if you so clockwise that time, H3 dot, no not H3 dot, because what you can see, okay. So S3 2 means what, S3 2 means first of all you are rotating by 120 degree. So if I rotating by 120 degree, so H3 dot will come here, fine. Then H2 dot, okay. Now if you take perpendicular plane, so that time you will get this molecule, okay. The front face you will get, not the back face, the front face you will get, okay. This molecule you will get, okay. Then suppose I am doing this S3Q for another time. So that time what you can see, so that time basically H1 will go to there, okay. H3 will come here, H2 will come here, but again you will see the back face, okay. You will see the back face. Now if I operate this, okay, S34, okay, S34, that time what I can get, so boron is there, so rotate by 120 degree and then take the perpendicular plane xz, you just operate sigma xz. So basically H2 will come here, if you take perpendicular plane you will see the back face, front face. H2 will come to here, okay. H1 will come to here and H3 will come to here. This is your S34, okay. Now if I operate S35, so that means again you are doing this. So what I am getting here, S35, so basically H3 will go there, you will get the back face. H2 will be here, you will also get back face here, and H1 will be here, here also you will get the back face, okay. S35, and next you have what, next you have S36, okay. So if I operate S36, what you are getting, boron, okay. Then check what you are, H1 is coming to here, H3 is coming to here, and H2 is coming to here. So basically if you see, if I operate this S3 axis for 6 times, so what I am getting, I am getting the identical structure, okay. I am getting the identical structure. So what I can say, that I have to operate the S3 axis for 6 times, okay. Then only I am getting this identical molecule, okay. So basically I can write down here that number of operation, that is equal to what, that is equal to 6, okay. Number of operation is equal to 6, okay. Fine, clear. So I am just doing this thing, you just rotate by 120 degree around your C3 axis, then you just take the perpendicular plane, that is your S3 axis, okay. So that is your S3. Now similarly, suppose here I have what I have, same molecule I am taking here, boron, here what I have, here I have H2, here H1, H3. So this is the BH3 molecule we have. Now if I rotate by 120 degree, okay, if I rotate by 120 degree in clockwise motion, okay, so what will happen, H1 will come to here, H2 will go to there, and H3 will come to here. So this is your C3 axis. Okay, now if you take the perpendicular plane, okay, so what I am getting, if I take the perpendicular plane here, sigma xz basically, so you will see the back face of this molecule. You will see the back face of the molecule. Okay, now if I do like this, that suppose C3 square. So C3 square means what? C3 squares means you are rotating this molecule by 240 degree basically. Okay, not 120 degree, you are rotating by 240 degree. So that means what, H3 will go to there, then H3 will again rotate. So basically H3 is coming to here. Okay, here what you have, H1 uh, C3, okay, sorry, so here you have C3 1 and here I have C3 2. So okay, sorry, so here you can say that I am rotating again by 120 degree. So if you rotate by 120 degree, so that means H3 is coming to here, okay, H1 is coming to here, okay, and H2 is coming to here. Then if you again take the perpendicular plane, which is your sigma xz, so that time what I will get, so that time I will get here H3, here you have H2, and here you have H1. Okay, now see, if you operate, you can get directly this molecule if you operate S3 square for a time. So just keep in mind, S31 means what, S31 means what you will get, H1 will come to here, H1 will come to here, H2 will come to here, H3 will go to there. So that is your S3, and you will get the back face of that. Now if you again operate S3 operation, so basically H1 will come to here, H3 will go to here, and H2 will come to here. Okay, so you just operate S3 square on this molecule, you will get this. Okay, or I can say if you operate C3 square, okay, so here you can rotate by 240 degree. If you rotate by 240 degree, check, you are getting also this molecule. Okay, you are also getting this molecule. Fine. So basically this number of operations you have to find out, or you have to know how to find out the number of operations. Now this in exam basically we do not have that much time that we will operate each and every operation, then we will check. So we need to find out some shortcut, right? So just keep in mind that if you have sigma to the power any odd value, okay, suppose you have sigma 1, sigma 3, okay, or sigma 5, sigma to the power any odd value, so that is basically equal to sigma. Okay, or if you have sigma to the power even value, suppose you have some even value to the power, sigma to the power some even value, so that will be equivalent to your identical molecule E. Okay, so these are the things, sigma to the power odd means sigma, and sigma to the power even means E, identical. Now suppose I have this S, then you have here A, here you have B, so that means S A to the power B. And if, write down that B less than A, if it is that, okay, so here S A B, and here what is the condition, that B should be less than A. Okay, B should be less than A. Okay, if not, okay, then this B will be your b minus a. Okay, if not, then b will be equal to what? B minus a. So initially you will have this s a to the power b. Okay, s a to the power b, and b should be less than a. If b is not less than a, so that if not, then b will be equal to what? B will be equal to your b minus a. So basically I can write down this like this, that is 3 1. So that will be equal to what? That will be equal to your C3 1 into what? Sigma 1. C3 1 into sigma 1. Okay. Now suppose I am writing this S3 square, S3 2. So that means what? I have to write down C3 square into sigma square. Now sigma square is equal to what? Okay, C3 1 into sigma 1, that will be equal to what? That will be equal to S3 1. But here sigma square means what? Sigma to the power even means identical, right? E. So I have to write down that C3 square into E, and if you multiply any operation with identical, so ultimately you will get that back. So C3 square. Okay, if you have this s3 to the power 3, so that means what? That will be your c3q into sigma q. Now sigma odd means what? You will get sigma, right? And c3q, so if this a is equal to b, so that will be equal to your identical e. Okay, so e into sigma q, so sigma to the power odd means sigma, so basically you are getting sigma. Okay, now suppose I have s3 4. So s3 4 means what you have? You have c3 4 into sigma 4. So now see, c3 4. So basically if this value is getting higher, no, so that time what you can write down? B is equal to b minus a. So I can write down that c3, and here also I can write down 4 minus 3. Okay, and this sigma to the power 4 means sigma to the power even, that will be equal to also identical e. So 4 minus 3 means what you are getting? C3 1 into identical, so that will be equal to what? C3 1. Okay, suppose you have s3 5, sorry, s3 5, so that will be equal to what? C3 5 into what? Sigma 5. Now C3 5 I can write down like this, C3 now 5 minus 3. If this value is getting higher than your this value, that b value is less than a value, that is fine. But if b is becoming greater than a, that time you have to do this b minus a. So here also I am doing 5 minus 3, and sigma to the power odd means you are getting sigma. So what I am getting? I am getting c3 square into sigma, c3 square into sigma. So that will be what? That will be your s3 square. Okay, c3 square into sigma, so that will be your s3 square. And another thing left, so s3 6. Okay, that will be what? That will be c3 6 into what? Into sigma 6, right? c3 6 into sigma 6. Now this c3 6, okay, this c3 6, so basically you can write down c3 into what? 6 minus 3, and sigma to the power even means what? Identical. So basically what I am getting? c3 3 into identical, and c3 3 means it is also your identical into identical, so you are getting identical. So in this s3, okay, if I write down s3 1 to s3 6, how much you are getting? Number of operations s3 1, and here you are getting s3 2. Okay, so you can write down here that number of operations in number of operations in s3 is equal to what? 2. We have only 2 operations in s3. What are they? So they are s3 1 and s3 2. s3 1 and s3 2. Fine, s3 1 and s3 2. Now next, we will find out for S5. So if I have S5 1, so S5 1 means what? You can write down like this: C5 1, okay, into sigma 1. So this C5 1 into sigma 1, that will be also equal to your S5 1. Now you just write down here S5 2. So that will be what? That will be C5 2 into sigma square. So sigma square is equal to what? E. So you just write down C5 2 into sigma square is equal to E. So that means what? C5 square. Okay. Next you have S5 3. So that will be what? That C5 3 into sigma q. So C5 3 means what? C5 3. So you can keep it C5 3, and sigma q. Sigma odd means you can write down sigma. So C5 3 into sigma, that will be equal to what? S5 3. Okay. So here you are getting back S operator. Here also you are getting back S operator. Okay. Now next, suppose you have S5 4. So that will be equal to what? C5 4 into sigma to the power 4. So this sigma to the power 4 is actually equal to what? Identical. So you are getting only what? C5 4. Now suppose you have S5 5. So that will be equal to what? C5 5 into sigma to the power 5. So C5 5 means what? It is actually equal to your identical, and sigma to the power odd means sigma. So you are getting only sigma. And another left, that is your S5 6. So S5 6 means you can write down S5, sorry, S5 6 means what? C5 6. Okay, so C5 6 into sigma to the power 6. So C5 6 means what? C5, and here you can write down 6 minus 5, and sigma to the power even means what? Sorry, sigma to the power even means what? Identical, right? Sigma to the power 6 means what? Identical. And 6 minus 5, so what you are getting? C5 1 into identical. So basically you are getting what? C5 1. So this is your S5 6. Now next you have S5 7. So that will be equal to what? C5 7 into sigma to the power 7. So that means C5 7 minus 5, and sigma to the power odd means again you are getting sigma. So what I am getting? C5 square into sigma. So C5 square into sigma means what you are getting? S5 2, right? Now suppose you have S5 8. So that will be equal to what? C5 8 into sigma to the power 8. So C5 8 means what? You can write down, I am writing directly 8 minus 5, so that means 3. And sigma to the power even means identical. So basically you are getting C5 3. Now suppose you have here S5 9. So that will be equal to what? C5 9, okay, into sigma to the power 9. Now this thing C5 9, this is basically what? This is basically your C5 4, because 9 minus 5 is equal to 4, and sigma to the power odd is equal to sigma. So C5 4 into sigma, that will be equal to what? That will be equal to your S5 4. So this is another, and one thing left, that is what? That is your S5 10. So if you have this, so I can write down C5 10 into what? Sigma 10. So C5 10, that you can write down C5 5, and sigma to the power even means what? Identical. So C5 5 means identical. This is also identical, so you are getting only identical. Okay. So what are the things you have? What are the operations you have? S5 1, S5 2, S5 3, and S5 4. Okay, these are the operations we are getting, right? So write down that number of operations in S5, that is equal to what? That is equal to 4. Number number of operations in S5, that is equal to 4. Okay. So write down here that if n is equal to odd, if n is equal to odd, then Sn Sn will have n minus 1 number of operations. So if n is equal to odd, then Sn will have n minus 1 number of operations. Okay, so you can write down easily. Suppose you have S3. So if this n value is odd, okay, if this n value is odd, so you will have n minus 1 number of operations. So 3 means 3 minus 1. So you will have 2 operations here. And what are the 2 operations you will get here? So you will get S3 1 and S3 2. Okay, suppose you have S5. So that means n minus 1. So basically 5 minus 1 is equal to 4 operations you will have. What are the operations you will have? So S5 1, then S5 2, then S5 3, and next will be your S5 4. Now suppose you have S7, so here you will have 7 minus 1, 6 operations. What are the 6 operations you will have? S7 1, A7 2, A7 3, A7 4, A7 5, A7 6. Now suppose you have S9, so that means you will have 9 minus 1, 8 operations you will have. What are the operations you have? S9 1, S9 2, S9 3, S9 4, S9 5, S9 6, S9 7, S9 8. Okay, so these are the things you will have. Okay, like that you can do. So if you have odd, this n value is odd, so that means you will have n minus 1 number of operations. N minus 1 number of operations, and you can find out the operations like this. Okay, and from you can have a doubt that said why you are starting from S3, why not from S1? So you can try for S1. So if you have S1, that is basically equal to what? S1 is equal to, I can write down that C1 into sigma. Okay, now this C1 to the power 1, so C1 to the power 1 means what? This is your identical E into sigma. So if you have only sigma, so that means you are getting sigma. So basically S1 is equal to sigma. Okay, S1 is equal to sigma. And S3 will have 2 operations, S5 will have 4 operations, S7 will have 6 operations, and S9 will have 8 operations. So S1 is equal to sigma. Similarly, you can find out for S2. So S2 will be basically your what? C2. Okay, C2 no. S2 is equal to what? I can write down that, just a minute. So if I write down not S2, suppose this is your S1 to the power 1. If I am writing S1 square, so S1 square means what? I can write down C1 square into sigma square, C1 square into sigma square. So this C1 square, that basically you can write down what? C1 into 2 minus 1, and sigma square means what? This is your identical. So again you are getting C1 to the power 1 into identical, and C1 to the power 1 means what? Identical into identical. So overall you are getting identical. So s1 to the power 1, that will be equal to sigma, and s1 square will be equivalent to your identical. Okay, and keep in mind this s2, okay, this s2 is equal to I, inversion center. If you are getting s2, that will be equal to inversion center. Okay, you can do it also. If you do it, so basically suppose s21 means what? So you will get c2 into sigma xy, right? C2z into sigma xy, you will get inversion center. Okay, now suppose you have s2 square. So if you do s2 square, so again what you are getting, c2 square into sigma square, right? So c2 square means what? This is also identical. Sigma square means what? This is also identical. Overall you are getting identical. Okay, so we have done for what? We have done for s3 and s5 we have done. Okay, s1 we have done, s2 we have done, s7 s9 we have done. Now just try for the even ones. Okay, so suppose I am trying for s4. Okay, s4 1. So s4 1 means what? S4 1 means you can write down c4 1 into sigma 1. So that is basically equal to your s4 1. Now suppose you have s4 2. So that will be equal to what? That will be equal to your c4 2 into sigma square. Now this c4 2, okay, this c4 2 you can also write down like what? C4 2, if I cancel it out, so you can write down c2 1 and sigma square equal to what? E. So basically you are getting c2 1. Okay, you can cancel this out. Suppose you have s4 3. So that will be equal to what? That will be equal to your c4 3 into sigma q. So c4 3, keep it c4 3, and sigma to the power odd means sigma. So basically you will get s4 3. So this one is 1 and this one is 1, s4 3. Now suppose you have s4 to the power 4. So that will be equal to what? c4 to the power 4 into sigma to the power 4. c4 to the power 4 is your identical, and sigma 4, that is also identical. You will get identical only. Okay, now suppose you have s4 5. So you will get c4 5 into sigma 5. So c4 5 means what? c4 5 minus 4 into sigma 5. So that one I am getting what? c4 1 into sigma. So that one c4 1 into sigma for s4 5. Oh sorry, s4 5. Yeah, so basically here also you will get s4 1. So these two are same thing, s4 1 and s4 5. So no need to do that. Okay, you are getting the same thing again. So how many number of operations we are getting? So you are getting two number of operations here. So here this number of operations, okay, this number of operations will be 2 in your s4. Okay, in your s4 the number of operations will be 2. Similarly, if I try for s6, so s6 1 means what? s6 1 means s6 1 into sigma to the power 1. So that will be also equal to what? s6 1. Suppose you have a 6 2, so that will is equal to what? Say 6 2 into sigma square. So that means what? Say 6 square into sigma square means identical. So you just write down say 6 square. Then you have a 6 3, so that will be what? Say 6 3 into sigma q. So C6q, again you can write down this C6q. If I cancel out, so what I am getting? C 1 2, and sigma to the power odd means only sigma, so basically you will get S2. C2 into sigma, so you will get S2, and S2 is equal to what? S2 is equal to I you are getting. Now suppose you have S6 to the power 4, so that will be equal to what? C6 4 into sigma to the power 4. So C6 4 means what? So C6 4, if you cancel out, what I am getting? This will be 2, this will be 3, and sigma to the power 4 means identical, so that is equal to what? C3 square. Now suppose you have a 6 5, so that means what? That will be C6 5 into sigma to the power 5, sigma to the power 5. So C6 5 is basically your C6 5, and sigma to the power odd means sigma, so you are getting here what? S6 5. So here you are getting S6 1, you are getting S6 5, and another thing left S6 6, so that means C6 to the power 6 into sigma 6, so that is also identical, this one is also identical, you are getting identical. So number of operations, okay, this number of operations will be what? Only 2. Okay, so in S6 also you are getting number of operations is equal to 2. Fine, so these are the things, and these are the ways you can find it out. Okay, so basically if I try for now molecules, so suppose I have water molecule. Okay, if I have water molecule, so what is the point group we have for water molecule? C2V. And for C2V point group, what are the elements we have? So we have C2 axis, we have E identical, then you have sigma xz, then you have sigma yz. Now number of operations for C2 axis, it is your n minus 1, so it will be 2 minus 1 is equal to 1. For identical it will be 1, sigma xz will be 1, sigma yz will be 1. So total how many operations you are getting? In total you are getting 4 operations. Okay, then suppose you have ammonia. So suppose you have ammonia. So what I have? C3b point group. So in C3b point group, what are the things we have? C3 and 3 sigma v. Okay, so in C3 we have 3 minus 1 is equal to 2. Okay, and for 3 sigma v, okay, for 3 sigma v you will get 3 number of operations. So total, okay, and E remains, and for identical you will get 1. So 2 plus 3 plus 1, so you are getting total 6 number of operations. Okay, 6 will be the number of operations. So like that, by the point group you can find out the total number of operations. Now suppose I have PTCl4, so here the point group will be your D4H. So in D4H, what are the point group? First of all identical, then you will have C4 axis. Okay, apart from that you have 4C2, 4 sigma V, and you will have sigma H. So for identical you will get 1, for C4 axis you will get 3, and for 4C2 you will get, so C2 means what? C2 means only 1 is there, so that means for 4C2 you will get 4, For 4 sigma v you will get 4, and for sigma h you will get 1. So if you add them in total, how many you are getting? So 1 plus 3, 4, 4, 8, 4, 12 plus 1, 13. Okay, number of operations will be 13 in this D4H point group. Okay. Similarly, suppose you have here this H2O2 molecule. Okay, this H2O2 molecule. So here also you will have C2V point group. So in C2V point group, you can see you will have C2 and 2 sigma V, and you will have identical. So for C2 you will get 1, for 2 sigma V you are getting 2, and for identical you are getting 1. So in total you will have 4 number of operations you are getting for this C2V point group. Okay, so that is the thing. And now one thing remains here. Okay, one thing remains here. So that is your, suppose you know how to find out the point group now. Okay, that thing we know how to find out the point group, and we have to know how to find out the order of the point group, because that will be helpful when we will do uh, application of that. So basically, suppose you have CNV point group. Okay, CNV point group, that time the order will be 2n. So suppose you have C2V point group, so that means the order will be 4. If you have C3V point group, that means the order will be 2 into 3, 6. Okay, similarly for CNH, the order will be again your 2n. Okay, for CN point group, the order will be what? N. Suppose you have DN point group, it will be what? It will be your 2n. Suppose you have DNH point group, so that time it will be what? It will be your 4n. Suppose you have DND point group, so that time also the order will be what? 4n. Okay, if you have C1 point group, the order will be 1. If you have CS point group, the order will be 2. If you have CI point group, the order will be 2. If you have tetrahedral, that time the order will be 24. Okay, if you have octahedral, that time the order will be your 48. And for icosahedron, okay, IH, icosahedron, it will be 120. So these are the things. So in tetrahedral, if I talk about your tetrahedral, so here you have one identical, okay, 8C3. Okay, apart from that you will have 3 C2 axis, 6 S4 axis, and it will be 6 sigma D. You can find out for identical you will get 1, for C3 you will get 8 into 2, for C2 you will get only 1, so 3 into 1. Okay, for S4 it will be your I have 6S4. For sigma D it will be 6, so 8 to 16, 3, 19, 120, 26 for tetrahedral. Okay, fine. So I will check that also. So for tetrahedral, basically you have these elements. Okay, one identical elements. You will have 8C3, 3C2, 6S4, and 6 sigma D. Okay, so these are the elements you have for your tetrahedral point group. And now another thing, so that is basically your matrix representation of symmetry elements. Matrix represent of your symmetry elements. So suppose xyz is the Cartesian coordinates you have. So if I operate this identical operator on this xyz Cartesian coordinate, so what I will get, it will not change. You will get exactly the same thing, xyz. So if I apply identical operator on xyz Cartesian coordinates, so you will get xyz back.
এখন নয় একটু আগে ইয়াটা আসুক তারপর আমি দেখবো
xyz back.
দেখো চলে গেছে
So if you have this c2z, okay, if I apply this c2z axis on your xyz, so that we have done. Okay, so c2z means what you will get, so z will remain intact, other two we will change. So minus x minus y and z will remain intact. Z is not changing at all. Okay, so basically now you have to represent these things on your matrix. So how to represent on your matrix? So suppose I am operating this identical operator on this x y z Cartesian coordinates, so you will get back the same thing. Okay, x y and z. So if I write down this, what I will get, so basically I will get this x plus 0 into y plus 0 into z. Similarly here you will get 0 into x plus y plus 0 into z. Here also you will get 0 into x plus 0 into y plus z. So similarly you are getting this. So if I represent it in your matrix, so you have to represent like this: 1 0 0 0 1 0 0 0 1. And what I am taking common from here, I am taking common this x y z, x y z. So basically this is your identical operator. So I can write down that what I am getting, that E of xyz. So that what I am getting, I am getting this 1 0 0 0 1 0. Here also you are getting 0 0 1, and here I have what, x y z. So basically if I compare, what I can consider, that identical operator, or that is equal to, what is the matrix, 1 0 0 0 1 0. Here also you have 0 0 1. So this is basically your identical matrix. Fine, this is basically your identical matrix. Okay, so that's it for today. This character and trace, these things we will do in the next class, how to identify them or how to find out all the things. First of all, just revise up to that what we have done. So what are the things we have discussed today? So we, first of all, we have discussed that how to find out the number of axes. Okay, so yeah, group multiplication table. So you just see how to find out this C2b. We have these elements, C2z, sigma xz, sigma yz. Now we are multiplying each other. Next we are find out order of the point group. So first of all, we have to find out number of operations. We know how to find out number of operations. For Cn axis it will be n minus 1, sigma will be 1, inversion center 1, identical is also 1. Okay, now improper axis of symmetry, basically you will get s1 s2. So s1 is equal to sigma. Okay, s1 is equal to sigma, s2 is equal to inversion center I, and from s3 we are starting. So here I have shown how to find out. Now if you see here, so s3, for s3 operations, how many operations we are getting? Only 2 operations we are getting, s3 1 and s3 2. Okay, for s5 we are getting 2 operations, s5 1 and s5, sorry, for s5 we are getting 4 operations, s5 1, s5 3, s5 2, s5 4. So number of operations will be basically n minus 1. Okay, if n is equal to odd, that time Sn will have n minus 1 number of operations. So For S3 you will have 2, for S5 it will be 4, S7 it will be 6, S9 it will be 8. Okay, S1 is equal to sigma and S2 is equal to I. Now for even one, suppose you have S4 one, so here we are getting two operations. For S6 also we are getting two operations. Similarly you can try for S8 also, you will get also two operations. Okay, so now how to find out the point group with order. So if you see point group with the order, so CNB it will be 2n, CNH it will be 2n, CN it will be n, DN will be 2n, DNH it will be 4n, DND will be 4n, C11, CS2, CI2, tetrahedral is 24, octahedral is double of that 48, and icosahedron is 120. And matrix representation of symmetry element, so if you have operate identical operator on xyz Cartesian coordinates, so you will get back the Cartesian coordinates like that only. Okay, nothing is changing. And I showed you here how to find out the identical operator or identical matrix. So this identical matrix is equal to what? 1 0 0 0 1 0 or 0 0 1. Okay, so that's it for today. We will continue tomorrow from the next topic. Okay, thank you, bye.